These notes are on the quadratic functions. Quadratic functions. So the first thing that I want you guys to do is recall the form that we were using to graph quadratic equations. So when graphing, we used the form y minus k equals a times x minus h quantity squared, knowing that the vertex was located at h comma k, where h is the x value of the vertex, k is the y value of the vertex. Quadratic functions, when we graph them or when we try to graph them, we're going to be looking at them in standard form, putting them in this form, and then graphing them with the techniques that we already learned. So our goal today, or for this part, goal is to take quadratic functions, so f of x equals ax squared plus bx plus c, and change them into this form, y minus k equals a times x minus h quantity squared, and then graph them. Then graph. So we're going to graph quadratic functions by taking them from this form, putting into a form that we recognize, that we already know how to deal with, and then we'll be able to graph it. So first example, graph g of x equal to 7 minus 12x plus 3x squared. So this is not exactly in standard form, so we can put it into standard form by making the x squared term come first. So we'll have 3x squared, the x term coming second, minus 12x, and then the c term plus 7. The reason why we put it into standard form is so we can identify a, b, and c without making any mistakes. So a is 3, b is negative 12, and c is 7. Okay? So we figured out a, b, and c. What are the other things we need to figure out? We need to know what k is and what h is. Then we can put it into this form. So to find h, there's a little formula that you'll need. So this is it. H will always equal, from standard form, the opposite of b over 2a. Okay? And that's the a and b from standard form. That's why we need to find a, b, and c. So h in this case is the opposite of negative 12, because that's b, over 2 times a is 3, so 2 times 3. So h equals positive 12 divided by 6, which is 2. H equals 2. Alright, now how do we find k? Well, I said earlier that h was an x value. So since h is an x value, I can plug it into my equation and find the y value, which would be k. So to find k, I take h and plug it in for x. So k will equal whatever I get when I plug in 2 for x. 3 times 2 squared minus 12 times 2 plus 7. And that is, well, 2 times 2 is 4, times 3 is 12, minus 24 plus 7. So k equals 5. So we have h, we have k. What else do we need in here? We need a, but a happens to be the same thing as it was when the equation was in standard form. So we have all the information we need. So y minus k, so k was 5, so y minus 5 equals a, which is 3, times x minus h, and h was 2. We found it to be 2. Quantity squared And then we can graph this using the techniques from the other section by getting a helper equation, which in this case, getting rid of the h and k. So I'll have y equals 3x squared, and making a t-chart, x and y. I'm just going to do -1, 0, 1. -1 squared is 1 times 3 is 3. That's 0 and 3. I'm going to quickly glue in graph paper. So the way I can graph this is by first plotting the vertex, and the vertex is h comma k. So that is 2 comma 5. So I first plot 2 comma 5. 1, 2, 1, 2, 3, 4, 5. A is positive, so it opens upwards. So I'm going to label downwards 2 comma 5. Create my new coordinate system with the origin being my vertex, and then plot these points. -1 and up 3. 1, 2, 3. And it'll look the same on the other side because of the axis of symmetry. And I just produce a graph. Okay? Nothing really different from last section, except for we're going from this form into this form. So standard form into the form we were using for graphing. So let's write down the steps. Step 1, get into standard form. Get into standard form. So we took g of x, put it into standard form. Step 2, find a, b's, and c's. A, B, and C. Step 3, find h by using this formula. This is important. I'm going to highlight it in green. We have a formula for h. So to find h, or find h, using the formula, it'll always be this, the a and b coming from the standard form. Whoops, we don't have 2 3's. It's 4. Step 4, find k. So plug in h. This is how you find k. Plug in h to find k. Step 5 is to write in the form y minus k equals a times x minus h quantity squared. So write in form y minus k equals a times x minus h quantity squared. And 6 is to graph it. That's it. We have a formula to find h. Plug it back in here for x to find k. A will always be the same. That's from standard form. And I mean, then it's stuff that you know already. So let's look at another example. In orange. So how about, we're graphing f of x equals, 4 minus 2 times x minus 1 quantity squared. What we could do is multiply this out and then put it into standard form and do the same steps that we did up here. But I think there would be something that's a lot quicker for this one. When you have something like this, quantity squared, take a look and see if you can use the method I'm about to show you. So we'll change the f of x to a y. 4 minus 2 times x minus 1 quantity squared. And then get this constant term over. Subtract 4 from both sides. So I'll have y minus 4 equals negative 2 times x minus 1 quantity squared. This is in the form y minus k equals a times x minus h quantity squared. That's the form. That's all we had to do. Now we can graph it like we normally have been doing. So v, in this case, will be positive 1. K is 4. So the vertex is 1, comma 4. The helper equation will be y, I'm just taking off k and h, y equals negative 2 x squared. So right now I'm going to glue in another graph. Yeah, so I can make a t-chart from this helper equation. I'm going to use negative 1, 0, 1, and I'll get negative 2, 0, negative 2. So I'll first plot my vertex, 1, 1, 2, 3, 4. And this one's opening down because A is negative. So I'm going to write my vertex on the top, 1, comma 4. And then I have my new set of axes, my new coordinate system, where the vertex is the origin. And I plot these points, negative 1, and then negative 2. 1, 2. And then reflect it over. And then I have a beautiful parabola. Oh, it's so cute. It's so cute. It's not funny. I don't know.